Now let's think about capacitors in series. So I've got two capacitors arranged like this, and let's call the left one C1, the right one C2. And again, I will flow in some current I on the left and take the same current I out on the right. As I do that, I will start to build up some positive charge on the left plate of C1, and I'm sucking away positive charge from the right plate of C2, leaving behind some negative charge. There is a central H-shaped piece of metal here that consists of the right plate of C1, the left plate of C2, and the wire that's connecting them together. That H is not connected to the rest of the world, so it has to remain overall electrically neutral. So we know that the charge on this left plate is going to be plus capital Q. I'm pulling the same current out here, so that means this will be negative capital Q. I'm going to attract some amount of charge, negative charge, to the left side here. We'll call that negative little q. And the total charge on the H has to be 0. So an equal charge plus Q will be attracted over here. Now, after we've done this briefly, we're going to cut off the current flow and just think about the situation as viewed from a point here within this wire that's connecting them. So we've cut off the current flow now, and we're just leaving, so disconnected the circuit from everything else. We're leaving everything at equilibrium. We know in equilibrium the total electric field inside this wire has to be equal to 0. Now, if little q were bigger than, if capital Q were bigger than little q, I'd have a total positive charge to the left side of this point and a total negative charge to the right side, which would mean that I'd have a net electric field pointing from left to right. So E would point right. And we know that that can't happen because the electric field has to be 0. And similarly, if big Q were less than little q, E would point to the left, and that can't happen. So put those two things together, that means that big Q has to equal little q. That is, the situation is like this, where I've got big Q here, minus big Q here, big Q here, minus big Q here. That's essentially a consequence of the fact that for two terminal devices that are in series, the current flowing through them is the same. As viewed from the outside world, if I again put a box around this, the total voltage difference from the left side to the right side is equal to the sum of the voltage differences across each capacitor. So I've got voltage V1 across this left capacitor, voltage V2 across the right capacitor, and the total voltage is the sum. Again, like we did for the case of the parallel capacitors, I want to think of the equivalent capacitance. C equivalent would be equal to the charge, and as seen from the outside world, that's just plus Q on the left, minus Q on the right, divided by the total voltage. It's actually helpful to take the inverse of this relation. So 1 over C equivalent is equal to V total divided by Q. Using this equation, that's V1 over Q plus V2 over Q. And we recognize, oh, that's just 1 over C1, and this is 1 over C2. So this gives us that 1 over, I'll call it C parallel, the equivalent capacitance for capacitors. Darn it, I made the same mistake. 1 over C series is equal to 1 over C1 plus 1 over C2. And if I had multiple ones in series, I could just continue to add them up like so. So in conclusion, when we have capacitors in parallel, the capacitances add, but when they're in series, as we can see from this, the inverse capacitances add. Let's just do an easy numerical example. Let's say if C1 equals C2 equals 1 microfarad. If I put them in series, I have 1 over C series equals 1 over 1 microfarad plus 1 over 1 microfarad. And so if I take the sum of those, that's equal to 2 inverse microfarads. So 1 over C series is 2 inverse microfarads. That means that C series is equal to 1/2 of a microfarad. So the series capacitance is smaller than either capacitor by itself. If instead I put them in parallel, I'd have C parallel equals C1 plus C2 equals 2 microfarads. So when you put capacitors in parallel, the total capacitance becomes bigger. When you put them in series, the total capacitance becomes smaller.